welcome to the session. Greeting of the day. In today's class, we are going to see about the other welding methods of brazing. In earlier classes, we have classified the welding processes in such a way. We have done the classifications of welding in this format of gas welding methods, with respect to shielding gases of flame, and then electric arc method, resistance heating methods, solid state welding method, chemical reaction of the thermite welding process, and other radiant energy process of electron beam method, laser beam welding process. The other welding methods of soldering and brazings are there. So in the previous classes, we have seen about the soldering, which is the welding process takes place at less than 450 degrees centigrade, and the brazing process takes place greater than 450 degrees centigrade. In both cases, the melting of the workpiece will not happen. Therefore, this brazing process and the soldering process will be helpful in welding of only melting and depositing methods. The brazing is when a filler material or alloy is heated to a melting temperature above 450 degree centigrade. That is what in soldering method we have seen it is less than 450. But now in the brazing methods we are seeing it is in the greater than 450 degrees centigrade. But for the both soldering and brazing, melting of the workpiece will not happen. Melting of only the soldering wire, the filler wire will melt and deposit and fills the gap with a principle of capillary action. In case of only filler metal melts, there is no melting of workpiece. So that is a very important point we have to note down. So brazing is when a filler metal or alloy is heated to its melting temperature above 450 degree centigrade. It is then distributed in a liquid from between two or more closely fitting parts by capillary actions that we have been able to understand. The filler metal is brought slightly above the melting temperature. So what we are doing, we are taking lightly above the melting temperature in such a way filler metal will melt and it will be deposited. It then interacts with the thin layer of base material known as wetting action and is then cooled quickly to make the welding process successful by the capillary actions. You can see here they want to weld a gap. They want to weld a gap where they are using the as usual normal neutral flame is used. As like in the gas welding process, we are using the normal neutral flame. Heat is generated, but normal we are not supplying. We are not melting the workpieces. Instead of that, the gap is there here. You can see there is a small gap between the two pieces. That the gap we are filling by melting the filler wire above the 450 degrees centigrade, and then that will melt and deposited here. If you want to melt the workpieces, what happens? It is a steel. It consumes melting of 1500 degrees centigrade. Not even going there. Just a filler wire. See here, the filler wire is heated, melted above 450, and then it is deposited. The gap and welding will be occurred. Only the metal will go to the red hot condition. A simple red hot condition, so the welding is completed now. Only by using of capillary actions, this molten metal getting the fluidity and smoothly flows in and around the gaps. So such weldings are possible easily. You see, one more point they are going to weld here. Such way here, likewise, base metal not hot enough. Here, the base metal is not hot enough. Base metal is not heated. Only filler material is heated, and we are going to fill the gap. That's where we can able to understand. The brazing process, the same what? In the brazing operations, you apply heat broadly to the base material, broadly to the base material. The filler metal is drawn through the joint of create this bond and this capillary action takes place. The main difference what we are doing in the welding and brazing, how the welding and the brazing has been taken place in welding, both the base material and both the filler material, both will be melted. Therefore, both will be used for the positive welding process. But here, only the brazing treatment is filler material is melted to deposit only by using of the capillary actions. So various materials is aluminum, silicon, copper, phosphorus, copper, zinc, and the nickel copper. So such cases are possible to weld, and brazing temperature, I told you above 450 does not mean only 450. You see, for melting of the aluminum we are using 600. For melting of the copper we are using 1120. It means that we are not reaching the melting point of the copper. We are earlier to that we are doing the only filler material is melted. Parent material is aluminum, nickel, copper. But here the filler material is we have to use this such a cases of melting and depositing. Brazing is a production and the cost efficient because only the gap we need, the gap is filled. Then it is cost effective. We know that much more heatings are required to melt. Component distortions is minimized to eliminate this distortions. Distortion is very minimum. Cost effective. Base metal dilution is very low. Yes, it is not melted. Joining of the dissimilar materials can be achieved. We are keeping nearby two dissimilar materials and we are taking a filler wax, filler materials, melted, just deposited. Different geometry sizes can be welded, maybe large thickness or low thickness, maybe circular, maybe flat, any material can be welded by using this brazing treatment. Small and wide gap sizes can be welded, whether it is a small gap or it is wide gap, we are going to fill. The filler metal is going to consume, maybe more filler metal will be consumed, but even though it is possible to do, specialized labor is not required. So see some of the images I would like to show you for the brazing operations. You can see here, it's like normal welding operations, a large pipe with a different 1G to 6G positions. We have done the welding operations here, we have done here, we have done here and here, where all possible is just we are filling the gap with respect to consumable filler wire. So here we have done the brazing operations here. Here we have done the brazing here. These various operations are done above 450, only melting of the filler material, non-melting of the base metal components. So what are the advantages of this operations? You can tell joint which will any dissimilar materials. Number one, very important point. Dissimilar materials can be possible to do welding. The bond line can be very neat in appearance. So very smooth, you see, this one, it looks very smooth, no flux we are using, no filler we are using. Even if it is not used, there is no slag items not formed. Therefore it looks very smooth operations that you are looking. So it is very neat appearance. Brazing does not melt the base metal. Base metal is non-melted, not melted. Base metal, not melted. It allows much tighter control over the tolerance without the need for a secondary finishing operations. In other welding processes like SMIW, we can take, we should do grinding if it is a surface, smooth surface we are not getting. In case of solid state joining of friction welding process, the flash formations, those flash formations, if required, we should do the secondary operation to machine and we should make the round rod flat. So the smooth way. But the secondary operations are all not required here. There is almost no distortions. Why? If the distortions, where it will come, distortions will be available when high heat input and fast cooling, rapid cooling takes place. We are not even going for the high temperature. Just filler material is melted and it is deposited. No much heat is absorbed by the workpieces, then there is no such distortions are there. Possible to join non-metals like ceramics can be easily brazed to the each other of the other materials. So dissimilar materials can be done. So it contains a few limitations also. Brazed parts may not be put in an environment, it's not environmental friendly, which exceeds the melting point of the filler material. The filler material's melting point is maybe 600 or 450, whatever it is, but when the material is kept to the environment which is exposed to that specific temperature, filler material will be melted, then the gap welded consumes will be disassembled. Therefore, this brazing having such limitations. Brazed joints requires a high degree of base metal cleanness. If the cleanness is not there, some dust is over the surfaces where we are wanted to do the brazing operations. Some salts are there already, or dusts are there, not cleaning are there, oxides are there. In such cases, brazing filler material which is melted will not make a bonding with the base material. Then the brazing process will not happen. Therefore, it should be have a good cleanliness on the workpieces where we are doing these brazing operations. Creating an aesthetic disadvantages, that is a joint color is often different from the top base material. You see, in the previous image we have seen the base material which is in the other color, and the welding operations which we have done in this other, because we are filling, we are not depend upon what is the main component of this stainless steel filler wire, that we are not. So that it is different looking from the aesthetic color differences will be there when we are looking over the joint, we can able to tell that belongs to brazing. As a good welding engineer, we can able to find that. So such cases are possible. So some of the other points are there. Any metals can be joined including dissimilar materials. Certain brazing methods can be preferred quickly because we don't heat much heat. If heating increases, we should concentrate more time. The time also it is getting reduced. Only filler material, small heat is needed to melt and deposit. Brazing can be applied to a joint of thin-walled parts that cannot be welded. In general, less heat and powers are required than in fusion welding process. In fusion welding, what we are doing? Fusion welding, both workpiece and fillers are melted. But what happens here? In the brazing, only filler material is melted, and therefore I am telling less heat inputs is required. Heat, when it is considered as fusion welding, consumes 100% of heat. This brazing consumes only 50% because one is heated, only one is melted, workpiece is not melted. The disadvantage is its joint is generally less than that of the welded joint. Strength factors are less. Having the strength factors are very less as compared to the welded joint. Although strength factors are good, brazed joints greater than that of the filler material, it is likely to be less than that of the base material. High service temperature may be weaken the brazed joint. That is what when the service conditions to be also to be considered while going for the process. The working condition is 450 or 600, and the brazing melting filler wire melting point is 600. Then when it will sustain there, it is not possible to sustain. So that ideas are there. So what I am doing here, I want to make a comparison to you. We have seen about the soldering, we have seen about the brazing. I want to compare these two. How we can compare? It is used in the electrical industry to join capacitors, resistors, wires, or everything. But here, in this it is used to our mechanical industries. Found that different metals can be joined here. The soldering process done at a temperature, how much? It is less than 450 degrees centigrade. Normally 200 to 230 will reach. The brazing is done at a temperature greater than 450 degrees centigrade. These joints are weaker than that of brazing. These joints are weaker than that of brazing. But you see, this brazing itself weaker than that of the actual welding processes like SMAW. As of now, we can tell soldering less than brazing less than SMAW process. Likewise, we can tell in soldering, an alloy of lead and tin is used as a soldering wire. Lead and tin, because it is melting point around 200, 400, we are using very minimum. And then brazing alloys, the copper and zinc is used as a filler material, commonly used. We are not dependent upon the material. Just the filler material to fill the gap using capillary action. Here the copper and zinc are melted and deposited, filling up the gap. That is why it is looking different color. Copper color we have seen in the image. See, this image we have seen such a different color because of copper and zinc. It does not need a special training to soldering. We have seen this component of soldering machine set up in every home. We have this, and usually we ourselves will do for connecting up two wires and some electronic components. So it does not need training. But brazing is not like that. It needs training to do the welding operations, because shielding gas neutralized flame to be prepared, then the filler wire double hand operations are there. So it is somewhat training required to practice on the shielding guns. So it is cheaper process. It is somehow costlier than compared to this. Soldering does not need a preheating of base material. The process needs some preheating operations. Preheatings are needed. Preheating not needed. Preheating not needed. Here preheatings are required. Needed. It is used to join electronic component, mostly used in electronic component. It is used mostly in the automobile industries. Such cases are possible. Now we come to some other few methods. We have to talk about the brazing of torch brazing, dip brazing, furnace brazing, and infrared brazing. Brazing does not mean you have to heat and supply greater than 450. But what I am doing, this type of process, when it is dipped, we will reach the temperature. Maybe to the torch, this image only we have seen now, torch method. To the torch, we have flame heating, temperature received, filler wire melted and deposited. Other methods of dip brazing, furnace brazing are infrared radiations brazing are there. The brazing methods of torch brazing, now only that we have seen what we have seen this one. This one we have seen as a torch brazing methods. Metal is there, filler wire, torch heating and melting. So very simple method. So other methods of dip brazing, where brazing joint to be kept inside the heating components. Assembled parts are typically dipped in a heated chemical bath, which serves as both fluxing agent and the heat source to melt and pre-applied filler materials. We are keeping the filler materials in the gas at a solid state, and we are putting it in the furnace or dip furnace. We are heating. In heating, automatically the filler will melt at that specific point, and there itself it is deposited. Such cases are possible. Furnace brazing, we are sending it to the furnace and taking out. And the filler materials are kept in the, as location. See, the filler materials are kept here. And then when it is heated, it is melted and it is deposited. Heated and it is deposited as usual. So such types are some other. Induction heating, we are using the electrical circuit for heating of the filler material. Flame heating, induction heating, furnace heating, dip heating. Such possibilities are there. So what is the advantage of this concerns? We can tell we are getting the narrow heat affected zones, non-contact process. Such other cases are possible. The summary: in welding process, in other welding processes, we have seen about brazing operations. This brazing operations takes place which is greater than that of 450 degrees centigrade in general, and we have seen this Soldering also, which is takes place less than 450 degrees centigrade. When you are comparing this soldering and brazing, it is greater than 450 degrees centigrade operation temperature, and this soldering is less than 450 degrees centigrade. But at both cases, filler material only melts. Workpiece not melted. Not melted. The remaining part of the circuits we will see in the next session. Thank you.